Hello, it's me, Mr. Werger. I am here today to teach you about something called an ellipse. First I'm going to show you how they are drawn. I've got a piece of string here with a couple pieces of tape on the end. Okay, so I'm going to tape this string to the board like that. Then I'm going to take my marker and stretch as far over to the left as I can, and then start moving my marker, using the string as a guide until I get up to there. And do the same thing for the top half of the ellipse. So I'm coming around. Oh no, my tape came undone. Let's try that again. Okay, so something like that. So this oval shape here is called an ellipse. Pretty cool, huh? Okay. I call this a long ellipse because it's kind of being stretched in the horizontal direction to make it longer. My two anchor points, those are called focus points. So those are across from each other in the horizontal direction. I could also draw an ellipse. Goodbye to you. If I anchor my two focus points in the vertical direction, like that. Hopefully those stay where they are. That. Ooh, that's a good one. And around that. Okay. So that's also an ellipse. It's like an oval shape. I call this a tall ellipse because we're kind of stretching it to make it taller. Okay. So if you are actually drawing a real true life ellipse, that's how you do it. So you're not going to draw them with string because, a piece of paper, it would be very tiny and that wouldn't really work. But that's the general shape of an ellipse. Move my camera over to the smartboard here, and we're going to hope that this doesn't fall down. Please don't fall down. Okay. So here we are on the smartboard. If I draw, so let's just draw an ellipse. It's kind of a random ellipse in quadrant 1. Okay. So the components of an ellipse. So an ellipse has a center. You'll see some similarities between ellipses and circles. So I hope everyone saw the circle video if you were not here on Wednesday. So just like the circle, for an ellipse, we're going to use H and K to represent the center of the circle. And we'll get to the equations down here in a second. So as you can imagine, the center is in the center of the ellipse. Okay, so a circle would have a diameter, which would be the same all the way around. An ellipse has what's called a major axis and a minor axis. The major axis is the longer axis. And its length is equal to 2 times A. So in this long ellipse, the major axis would go across like that. It goes through the center from like the leftmost point to the rightmost point in this case. So that's the major axis. And then if we draw another axis that would be perpendicular to this, so in this case, the minor axis would go up, down like that. So the minor axis is the shorter axis. And the length of the minor axis is 2 times b. Okay? So minor axis is the shorter axis. Write that in there. Minor axis. Minor axis is the shorter axis. The major axis is the longer axis. Okay? So then here we have 2 equations for an ellipse. So we've got h and k, which represent our center. And then the a and the b values come from these numbers in the denominator. In the denominator, those numbers are a squared and b squared. A is always the bigger, so if you're wondering if these are 2 numbers and you're wondering, okay, which one is A and which one is B, A is always greater than B. Okay? So if we have an equation like this, so if the bigger number is with x, then that's going to give you a long ellipse. So if you want to draw a long ellipse there. And let's draw in here. Okay, so we said that the length of the major axis was 2 times a. So if the entire major axis is 2 times a, how far is it going to be just from the center out to the side there? It would be half of 2 times a, right? Which would just be a. Okay, so a is sort of like the, in this case, the horizontal radius. It's not really a radius though, because the radius would be the same all the way around. So it's the distance from the center out to the rightmost edge of the ellipse. Okay, and then the minor axis, I said, was 2 times the b. So if I just take like half of the minor axis, from like the center up to the very top, that distance would be b. Okay, hope that makes sense. So that's what the ellipse would look like if your bigger number is under the x. Okay, those could switch. So remember, a is always the bigger number. So if the bigger number is under y, so now we're going to get a tall ellipse. So draw yourself a tall ellipse. Okay, so now A is in the vertical or the y direction, or A is half of the major axis. So the tall ellipse, the major axis goes in the vertical direction, and the minor axis goes in the horizontal direction. So that distance from the center out to the right, that would be B. Okay, so A is not always horizontal, or it's not always vertical. It depends on if A is with x in the equation, or if A is with y in the equation. Okay? page, and let's draw some ellipses. Okay, so first thing you want to think about is where's the center? So we said the center was the h and k values. So those would be in the numerator here with x and y. Okay, so in this first example, there is no addition or subtraction with x and y. So what do you think that means about the center? Maybe you guess the center would just be 0, 0. Okay, so the center here is 0, 0. Okay, so you want to start at the center. Okay, so then here's our a squared and b squared values. So a squared is always the bigger one. Okay, so a squared is 25. But we don't want to know what a squared is, we want to know what a is, right? A is the distance from the center out to the edge of the ellipse. So whatever these numbers are, we need to take their square roots. Okay, so a would be 5. And b squared is 16. So b would be 4. Okay, so the bigger number is with x, so this is going to be a long ellipse. So starting at the center, I would want to go 5 units out to the right. So put a point there at 5, 0. 5 units to the left. So put a point there at -5, 0. So there's your major axis. Total length is 2 times a, so that total length is 10. Okay, then in the y direction, we need to go up 4, so point 0, 4, and down 4, so 0, -4. So there's your minor axis, which length is 2 times b, so that's 8. And we now know what an ellipse generally looks like. It's an oval shape. So using those 4 points, draw your best ellipse. And they're not super easy to draw, so I like the bottom of this more than the top. A little off there, it looks a little lopsided, but you get the idea, right? Okay. Example 2. You want to try that one on your own? Let's identify the center first before we give that a try. So here we've got some h and k values. And just like with circles, so if you've got addition in here, that's the same as subtracting -3. So the x-coordinate would be -3. Y-coordinate is +4. Okay, so we will start at -3, +4. There's your center. So why don't you take a minute to find your a and b values and sketch the ellipse. Just go ahead and pause on the video. And the ellipse does go off the graph just a little bit, so don't worry too much about that. Okay, so a squared is 100. Square root, so a is 10. B squared is 64. Square root, so B is 8. Okay, and again the 10 is with x, so in the horizontal direction I want to go 10 to the left. And I'm starting at -3, so I'm going to need to go out to like -13. So yes, we do go off the grid a little bit there. 10 this way would put us at 7. And then we need to go up 8. Okay, so we're going to go off in this direction too. We need to go up to 12. So right there. And down 8 would put us at -4. Let's see if we can get a little bit better looking ellipse this time. It's kind of like the bigger they are, the harder they are to draw without trying to keep it, symmetrical and everything. Okay. Hopefully that all makes sense. And these examples did have perfect squares for a squared and b squared. That won't always be the case. So let's say this was 10. So then a would be like the square root of 10, which is not a perfect square. It's like 3.1. So just do kind of your best to estimate, 3.1 as opposed to 3. There won't be a huge difference there. So I don't want you to think that a squared and b squared are always going to be perfect squares. Okay, then the last part of this, and we did this with circles, taking an equation for an ellipse and rewriting it in standard form. So standard form were these equations, where you have the x minus h squared, y minus k squared, that whole thing. Okay, so we're going to do that with an ellipse as well. So if you remember with circles, our first step was to look at the leading coefficients and just divide every term by the leading coefficients. Okay, so that works with circles, because with circles, I don't know if you noticed this, maybe go back and take a look at your worksheet 4 for a minute, but the coefficients of x squared and y squared were always the same. And that's what makes it a circle. The coefficients of x squared and y squared are the same. Okay, so with an ellipse, those numbers are not going to be the same. Okay, so I can't just divide everything by 4 here. I mean, that'd be great for x, but then I would have 9/4 y squared, and I couldn't go through that completing the square process, unless that's just plain y squared. Okay, so we gotta do it slightly differently. So first let's do some rearranging. So step 1, rearrange the terms. So the x terms and y terms are together. And if there's a constant, move that constant to the other side. Move constant to other side. Okay, so we would have 4x squared. And then next to that, put the minus 8x. Then put the y terms together, so plus 9y squared minus 54y. And then this 49, we want to move that over to the other side, so subtract 49. So this would equal negative 49. Oh, I hope you can see that. I'm right on the edge of the screen here. Let's slide it over maybe. Slide over. Hopefully that's a little better. Okay. Then next step, when we did this with the completing the square, when we were solving quadratics, we're going to do some factoring. Okay, so we're going to factor out the coefficients of x squared and y squared. Step 2, factor out the coefficients of x squared and y squared. Okay, so just show you what that looks like. So just for the x terms, I'm going to factor out a 4. So then I would have 4, parenthesis, x squared minus 2x. And you can check to see if that's right just by doing the distributive property. So if you did the distributive property, I get 4x squared minus 8x, right? So same thing. Then leave a space after that. So we're going to create a perfect square trinomial in a minute. Then do the same thing for y. So the coefficient of y squared is 9. So from just the y terms, factor out a 9. So then I've got y squared minus 54 divided by 9 is 6y. Leave a space there. I've run out of room. Ugh. If this was a more professional production, I would somehow edit this out, but it's not. And then we still got the minus 49 over here. Right? Okay. Then we create our perfect square trinomials. So step 3. Find half of that b value and square it for both x and y. Add these numbers to both sides. Well, no, I shouldn't say that. I should not say that. Let's come back to that. So new b value, after you do the factoring, look at the b value, not in the original problem. Half of negative 2, negative 1, negative 1 squared is 1. Okay, but then we saw this on Wednesday's lesson with completing the square. So if there's a number out here, we have to multiply those. So we really added 4. So on the other side of the equation, I need to add 4 times 1. So over here, I need to add 4. Okay? Do the same thing with the y terms here. So half of the new b value here would be negative 3. Negative 3 squared is 9. And that 9 is being multiplied by this 9. So on the other side, 9 times 9, we need to add 81. Okay. So then step 4 is to simplify. So we've got 4. Remember, shortcut, take half the b value, x minus 1 squared, plus 9, y minus 3 squared. Here we've got 85 minus 49, which is 36. Okay. And this should always be a positive number for ellipses. So let's say we had forgotten to multiply 9 times 9, and we just added 9 here instead of 81. So then we would have gotten negative 36. So that's like a red flag, like, whoops, something was not right there. So maybe go back and check and see, okay, did I multiply by those numbers that I factored out? This should always be positive. Okay, so we're getting closer. I don't think I mentioned before, so let's mention it now. Maybe you noticed. These equations for ellipses in standard form, they're always equal to 1. Always equal to 1 when it's in standard form. Okay, so the last thing I need to do here is make this equation equal to 1. And you want to use division to do that, as opposed to like subtraction. So step 5, divide to make the equation equal 1. So that would mean dividing everything by 36. And then you're going to have some fractions here that can be reduced. So 4 over 36, think of that as a fraction. So that would reduce to 1 over 9. 4 goes into 36 9 times. Okay, so now that's our a squared value there, 9. Okay, and then do the same thing with y. So 9 over 36. 9 goes into 36 4 times, so this reduces down to 1 over 4. So I'm not writing the 1, it's multiplication. And then 36 over 36 is 1. Okay, so there's our ellipse in standard form. And did this say to graph it? Then find the center and sketch a graph. Yes. Okay, so a little bit more here. Make yourself a little XY axis. Okay, so identify our center. Our center is 1, 3. 3. A squared is 9. So A would be 3. 3 in the x direction. So go up to negative 2 there, out to 4 there. B squared is 4. So B would be 2. Y direction, down 2 and up 2. So this is a smaller ellipse. Draw a little better. Again, not my best effort. Feel free to draw something better looking than that. Okay, but that would be our ellipse. Okay, so I hope that all made sense. The homework is worksheet 5, so that should be the next worksheet after the notes from this section. If you're watching this in first hour, I should be back real soon. We'll go over your homework assignments, and if we need any clarifying questions, we can do that. If you're watching this at home, and are confused about anything, come in before school as early as possible to get some extra help. This next week's lesson on hyperbolas is going to be similar to this, and kind of snowballs on you as far as not understanding what's going on, so try to get caught up right away. All right, have a good day.